Hello everyone. Welcome to our channel GeoSkills. Today, we are unveiling the world of remote sensing and exploring its definitions and applications. Remote sensing is a technology that allows us to gather information about our surroundings without any physical contact. Let's explore the definitions and applications of remote sensing. In its broadest sense, remote sensing is the acquisition of information about an object without being in physical contact with it. Of the 5 human senses, we use 3 as remote sensors. These sense organs are virtually organic forms of remote sensing. The eyes accept light signals and the ears accept the sound. So, remote sensing is a day-to-day activity. Reading the newspaper, listening to music, watching TV, and looking at a lecturer during a course are all remote sensing activities. When we observe an object through our eyes, we are actually engaged in remote sensing. In that case, our eyes act as remote sensors. The human eyes register the solar light reflected by those objects. Thus, remote sensing is defined as a way of collecting and analyzing information or data about an object without being in direct contact with the object. As we all know, in its literal sense, remote means far away or something that is not exactly in contact or in physical contact, and sensing means observing or acquiring some information or data. Remote sensing is the process of acquiring information, that is sensing, from a distance or remotely. Thus, remote sensing means the acquisition of information about features without coming into physical contact with the features. So, what exactly is remote sensing? Now, let's explore different definitions of remote sensing from various experts. From Colwell's reconnaissance at a distance to the American Society for Photogrammetry and Remote Sensing's description. In fact, the term remote sensing merely means reconnaissance or surveillance at a distance. According to the American Society for Photogrammetry and Remote Sensing, ASPERS, remote sensing is the measurement or acquisition of information of some property of an object or phenomenon by a recording device that is not in physical or intimate contact with the object or phenomenon under study. As Lintz and Simonet describe, remote sensing is the acquisition of information or physical data about an object without touch or contact. Or as Barrett and Curtis said, remote sensing is the observation of a target by a device from some distance away. To be more specific, the use of sensors to record electromagnetic radiation to image the environment, which can be interpreted to yield useful information. The use of sensors, normally operating at wavelengths from the visible light to the microwave, to collect information about the Earth's atmosphere, oceans, land, and ice surfaces. According to Barrett and Curtis, remote sensing is the observation of a target by a device separated from it by some distance. Remote sensing has been variously defined, but basically, it is the art or science of telling something about an object without touching it. According to Lillesand and Kiefer, remote sensing is the science and art of obtaining useful information about an object, area, or phenomenon through the analysis of data acquired by a device that is not in contact with the object, area, or phenomenon under investigation. Describing another way, remote sensing is the art, science, and technology of obtaining reliable information about physical objects and the environment through the process of recording, measuring, and interpreting imagery and digital representations of energy patterns derived from non-contact sensor systems. A general definition of remote sensing is the science and technology by which the characteristics of objects of interest can be identified, measured, or analyzed without direct contact. So, in simple terms, remote sensing is the acquiring information or securing of data about an object or phenomenon without connecting with the object, something like a photograph. Or to say that, remote sensing is the acquisition and interpretation of spectral measurements made at a distant place to obtain information about the object. Simple photography is remote sensing. Essentially, it is the science and art of obtaining information about an object, area, or phenomenon through the analysis of data acquired by a device that is not in contact with the object, area or phenomenon under investigation. It is therefore an attempt to measure something at a distance, rather than in situ measurements. Let's now explore the origins and history of remote sensing. The roots of remote sensing can be traced back to World War II. It was a period of use of radar, sonar, and thermal detection technologies. While the phrase remote sensing was not coined until the late 1950s. The term remote sensing was first used in the United States in the 1950s by the U.S. Officer of Naval Research. Thanks to the efforts of the Office of Naval Research, remote sensing has become so popular term. Remote sensing is the acquisition of information of an object or phenomenon by the use of either recording or real-time sensing device or devices that are wireless or not in physical or intimate contact with the object. Floyd Sabin further explains that the term remote sensing refers to methods that employ electromagnetic energy, such as light, heat and radio waves, as the means of detecting and measuring target characteristics. Remote sensing encompasses a wide range of applications, including Earth observation or weather satellite collection platforms, ocean and atmosphere observing weather platforms, the monitoring of a paroli via an ultrasound identification system, magnetic resonance imaging, MRI, X-radiation, or X-ray, and space probes are all examples of remote sensing. However, in common usage, remote sensing generally refers to the use of imaging sensor technologies including instruments found in aircraft and spacecraft, and is distinct from other imaging-related fields such as medical imaging. In essence, remote sensing involves obtaining information about an object by a device that is not in contact with the object. It is the process of acquiring information, detecting, monitoring, and analyzing the physical characteristics of an area by recording its reflected and emitted radiation energy without having any physical contact with the object under study. And this is done by capturing the reflected radiation energy. In other words, remote sensing means viewing something from a distance rather than by direct contact. Thus, a handheld camera is an example of a remote sensing instrument. In the context of Earth science, remote sensing refers to the ability of satellites to detect electromagnetic radiation from features on the surface of the Earth or in the atmosphere. Remote sensing is the use of various technologies to make observations and measurements at a target that is usually at a distance and to be more precise, at a scale or intensity beyond observable to the naked eye. In fact, remote sensing is all-inclusive. It is the science of identifying, observing, collecting, and measuring objects without coming into direct contact with them. In simple terms, remote sensing is the science of deriving information about an object from measurements made at a distance from the object, that is without actually coming in contact with it. The quantity most frequently measured in present-day remote sensing systems is the electromagnetic energy emanating from objects of interest, although there are other possibilities. As prescribed in the fundamentals of remote sensing, it is the science, and to some extent, art, of acquiring information about the Earth's surface without actually being in contact with it. This is done by sensing and recording reflected or emitted energy and processing, analyzing, and applying that information. Remote sensing is concerned with detecting and recording electromagnetic radiation from the target areas in the field of view of the sensor instrument. The human eye, however, is limited to a small part of the total electromagnetic spectrum, which is approximately 400 to 700 nanometers. On the other hand, in remote sensing, various kinds of tools and devices are used to make electromagnetic radiation outside this range from 400 to 700 nanometers visible to the human eye, especially near-infrared, middle infrared, thermal infrared, and microwaves. The characteristics measured by a sensor are the electromagnetic energy reflected or emitted by the surface of the Earth. This energy relates to some specific parts of the electromagnetic spectrum, usually visible light, but it may also be infrared light or radio waves. Common to all these definitions is that information or data on characteristics of the surface of Earth is acquired by a device, sensor, that is not in contact with the objects being measured. The result is usually, though not necessarily, stored as image data. Therefore, remote sensing refers to all these advanced instruments gathering different types of data that can be interpreted to derive accurate information about the surface of the Earth and the atmosphere. On technical grounds, remote sensing techniques involve the accumulation of knowledge pertinent to the sensed scene, target, by utilizing electromagnetic radiation by employing cameras, microwave radiometers and scanners, lasers, radio frequency receivers, radar systems, sonar, thermal devices, seismographs, magnetometers, gravimeters, and other sensing instruments. Defined thus, remote sensing is an act or process of acquisition of information. The most common remote sensing systems measure reflected visible light, but they can also measure electromagnetic radiation that is invisible to the human eye, for example, ultraviolet, UV, infrared, IR, or microwave radiation. In fact, the remote sensing device measures electromagnetic radiation in different spectral wavelengths to obtain information about the objects, features, or properties under the study. In 1993, the Journal of Applied Remote Sensing defined remote sensing as the science and technology by which the characteristics of objects of interest can be identified, measured or analyzed without direct contact. Remote sensing includes all methods of obtaining pictures or other forms of electromagnetic records of the surface of the Earth from a distance. Remote sensing is an advanced method of surveying and data analysis that uses airborne sensors to document important environmental or structural information faster and more accurately than ever before. When studying the Earth, we often use the term Earth observation, which primarily means information collected from Earth-observing satellites. It has emerged as one of the most fascinating subjects over the past 3 decades. According to James Campbell, remote sensing is the practice of deriving information about the land and water surfaces of the Earth using images obtained from an aerial perspective, using electromagnetic radiation in one or more regions of the electromagnetic spectrum, reflected or emitted from the Earth's surface. Describing remote sensing systems, Scovengert elaborates on it in more precise manner. It describes particularly those remote sensing systems deployed on satellites and that provide a repetitive and consistent view of the Earth, invaluable to monitoring the Earth system and the effect of human activities on the Earth. More precisely, remote sensing refers to the science of identification of Earth's surface features and estimation of their geobiophysical properties using electromagnetic radiation as a medium of interaction. Spectral, spatial, and temporal signatures that are major characteristics of the Earth. It facilitates discrimination between objects. Earth's surface as seen by the sensors in different wavelengths, reflected, scattered and or emitted, is radiometrically and geometrically corrected before extraction of spectral information. Remote sensing data, with its ability for a synoptic view, repetitive coverage with calibrated sensors to detect changes, observations at different resolutions, provides a better alternative for natural resources management as compared to traditional methods. Earth observation from space through various remote sensing instruments has provided a vantage means of monitoring the dynamics of the land surface, natural resources management, and the overall state of the environment itself. Remote sensing has replaced slower, costly data collection on the ground, providing fast and repetitive coverage of extremely large areas for everyday applications. It has even made it possible to collect data from dangerous or inaccessible areas, with growing relevance in modern society. Remote sensing technology has become much more prevalent, accurate, and accessible in recent years, and covers a wide range of applications. Now high-powered cameras are mounted on airplanes and satellites to capture images of the Earth as it changes over time. Other sensors such as LiDAR, light detection and ranging, are used to collect height data which can be used to measure how trees and forests and even developmental change over time. Remote sensors, which provide a global perspective and a wealth of data about Earth systems, enable data-informed decision-making based on the current and future state of our planet. The applications of remote sensing include land use mapping, weather forecasting, environmental study, natural hazards study, and resource exploration. It is applied in the fields of agriculture, archaeology, forestry, geography, geology, and others. American Society of Photogrammetry. Remote sensing is increasingly used to acquire information about environmental processes such as land cover changes, deforestation, urban growth, etc. And that concludes our exploration of remote sensing, the incredible science and technology that allows us to understand our world in ways we never thought possible. If you found this video informative, don't forget to like, share, and subscribe. Until next time, keep exploring the wonders of science with us. Thank you for watching.